Yes, I know it's a beautiful lecture. No, I know that. Okay, so we all agree. This is now something else. Okay, something else. Just at the end of this lecture, something else. Internal waves. Internal waves. Hard to spot them in the ocean, but we can spot them in the atmosphere. And here are some examples. Okay, we can spot the internal waves in the atmosphere in cloud patterns. Because you already learned this, that you can create clouds by lifting air upward. You can suppress clouds by lifting air masses downward. And if you do that in a systematic way, you can create cloud streaks, which are shown here on the top left. These streaks of parallel cloud bands. Okay. What also can happen in the atmosphere is you can have breaking waves in the atmosphere. And they're shown here in the cloud patterns at the tropopause. You can see breaking clouds. So it's a little bit more tricky in the oceans. So how do they look like in the oceans? Internal waves in the oceans. And here's one example of an internal waves. So internal waves are created in layered fluids. In a situation where you have light water sitting over denser water, you have an interface, and the interface can swing up and down, similar to the surface. The sea surface is also an interface between ocean, seawater, which has a high density, and atmosphere, the air, which has a low density. So very, very similar to surface waves, but also different. Okay? I tell you the key differences. The key differences are that the periods are much slower. Okay, so we're talking about periods of the order of 10 minutes or longer. Here's one example of an internal wave measured by repeated vertical profile of temperature. Okay, and you can see that there's cold water moving up and down, and you can estimate the period. Okay, for example, the x-axis is hours, and then during 1 hour you have something like 3 peaks of the wave. Gives you a 20-minute period, all right? Okay, the phase speed is much slower. Okay, the phase speed is much slower because the period is longer. Okay, and the period is much longer because the density difference between both layers is much smaller than that between seawater and the air above it. Okay, you can also spot internal waves because what they do at the surface, they can create a convergence, horizontal flows that converge and create slicks of floating matter becomes accumulated along the so-called slicks. And this is illustrated here in the top left. This is what we call an internal wave. Okay.